Geometry 6-6, trapezoids and kites. A trapezoid is a quadrilateral, not a parallelogram, quadrilateral with precisely one pair of parallel sides. So let's draw an example trapezoid. I've got one pair of parallel sides, and then I've got sides that are not parallel to one another. Here's a trapezoid, and this is trapezoid A, B, C, D. This is a base, and this is a base. So the sides that are parallel to one another are bases. And here's a leg, and here's a leg. That is the anatomy of a trapezoid. Now, a lot of times when we see trapezoids, we see isosceles trapezoids. And they look like this. They might be upside down. See how I call this upside down? Really doesn't have any orientation. But we've got bases that are parallel, sides or legs are congruent, base angles are congruent to one another. So this is an isosceles trapezoid. Notice how it kind of looks like an isosceles triangle, how the base angles are congruent and then the legs would be congruent here. So let's draw another one. And this is QRST. I've got a base and another base. I've got my legs are congruent. Now I am going to draw diagonals on this trapezoid. And these diagonals are congruent. QS is congruent to RT. Diagonals are congruent. So the diagonals of an isosceles trapezoid are congruent. Here's an example. So I've got this speaker, and it is an isosceles triangle, or an isosceles trapezoid. Okay, let's draw this speaker. It looks like this. And here's the speaker in the middle. So this is the cabinet, right? This is the speaker. Now I have my diagonals. Here's K. This is trapezoid FGHJ. JF is congruent to GH, and FG is parallel to JH. Did I say GH is parallel to FJ? Okay. FK is 8 inches. JG is 19 inches. Measure of angle J is 85 degrees. Now, when I say measure of angle J, I really mean angle FJH. So that's this FJH, this whole thing right here is 85 degrees. I want to know what is the measure of KH and what is the measure of FGH. Whew. All right, so we're going to walk through this one, and then I'm going to give you one to do on your own. All right, FK JK, that's this little piece right here, is 8 inches. Okay, JG, that whole thing, is 19 inches. I want to know what's KH. So I just want to know this piece here. I have this piece, and I have this hole. So I just need what's left over here, which is this piece, because these are congruent to one another. So I just need this little piece left over. So all I have to do is say 19 minus 8 is, what's 19 minus 8? I've lost my mind. 11. And so that means JK is 11, KH is 11. All right, let's find out FGH. FGH, that's this whole thing right here. All right, so this angle and this angle are congruent. This angle and this angle are congruent. This angle and this angle then have to be supplementary. So 180 minus 85 equals 95. Why do these have to be supplementary, I wonder? Because all of this is 360 degrees, right? And if this and these are the same, and this one are the same, if I were to like cut it in half of the angle measures, if I were to add these together, this should be half of the angle measures. And if I were to add these two together, that would be half of the angle measures. The whole thing is 360. That means this one plus this one is 180 because half of 360 is 180. So if I add these two together, they should be 180. I don't know if what I just said made sense or not, but of course it made sense. Perfect sense. You try this one now. I've got another isosceles trapezoid. And this is isosceles trapezoid X, Y, Z, W. X, W, and Y, Z are congruent. X, Y, and WZ are parallel. I have a diagonal coming through from X to Z and from W to Y. And in the middle, where they meet, this is going to be point V. Now, WV is 15, and VY is 10. Measure of angle, XWZ is, oh, I don't know. I'm not telling you what it is. This angle here is 45 degrees. Okay. I want to know measure of angle XWZ. I want to know measure of angle WXY. I want to know what is XZ. And I want to know what is XV. All right, so you've got 4 things to find here, given the information that you have. All right, so go ahead and pause, get to work on this, see how you do. All right, let's see. I would like to look at the sides first, I think, or the measures of the lengths here. So XZ is this whole thing here. And so I know this whole one, that's 15 plus 10, is this whole one, and these two are congruent, so this whole one, XZ, is 25, just like WY. So 10 plus 15 is 25. Okay, got that one fine. XV here, so XV, that's this smaller one on top. It's the same as this smaller one on top, it's 10. All right, those ones were not so bad. All right, now WZY is 45 degrees. What am I looking for here? XWZ. XWZ. All right, so that's just on the other side of this. And if this is an isosceles trapezoid, then I know that these two angles are congruent. So XWZ is the same as YZW, 45 degrees. Now I need WXY. WXY, that's this one right here. And we already talked about how these need to be supplementary. So I can just say 180 minus 45. And that is 135. Okay, we got just a little bit longer to go here. The mid-segment of a trapezoid. I'm actually going to flip my paper over. Mid-segment of a trapezoid. So we're going to draw a trapezoid. It is going to be not an isosceles trapezoid. I'm going to draw a segment that goes right in here, right in the middle of it. So this is my base, this is my other base. And when I draw a mid-segment here, this mid-segment is parallel to the bases. And when I draw this, it cuts this leg in half, and it cuts this leg in half. So notice the mid-segment parallel to the bases. See ya. And bisects the legs. So that's information to just put in your brain. And we are going to move on to kites, and then we'll be done with chapter 6. Kites. So to draw a kite, I usually draw the kind of a T first, sideways. I'm just drawing it sideways. And that makes it a little bit easier for me to draw the kite in a more in a better way. If I try to draw the outline of the kite, then it gets all floppy and weird looking. So here's my kite. My kite, instead of writing all that stuff we've been writing for every other shape, we're just going to label it here. So I've got my kite. I've got these two segments are congruent. These two long segments here are congruent. This diagonal bisects this diagonal. This diagonal bisects this angle and this angle. This diagonal bisects this angle. Oh no, it doesn't. Sorry. Nope, I didn't. Don't. The last thing we're going to say here is that this diagonal and this diagonal create a, they are perpendicular to one another. Now there is one other thing that we're going to draw here, but it's better if we just draw a whole nother kite. And we're going to draw this other kite without the diagonals. One more thing to know about kites. See how it gets all messed up when I don't draw the diagonals? One more thing about kites. Again, we have these two and these two are congruent. Also, this angle is congruent to this angle. So this whole angle here is congruent to this whole angle here. Okay. Now, let's do some examples. All right. I have a kite. Okay, it's a kite, all right. And it is kite F, G, H, J. And I know it's a kite because FG and GH are congruent, FJ and JH are congruent, and angle F is congruent to angle H. So I know this is a kite. Now angle G is 128 degrees, and angle J is 72 degrees. What is the measure of angle F? All right, give you a little time to think about it. So if you want to pause and see if you can figure it out, that'd be great. I'm going to keep going though. So remember that all of this is a quadrilateral. So I have all four angles. If I were to add them up, the interior angles, I should have 360 degrees. So 360 degrees is my total there. Now, if I were to add, I have these two angle measures. So this is 128 plus 72. And then I need to add these two angles here. So one way I could do that is to say, these are both the same measure. So let's just say they are angle X. And so if I have two of them, then I have 2X. And so I could add these two together. So that's 200. And if I subtract 200 from both sides, then I get 160 equals 2x. Divide by 2, x equals 80 degrees. So that's one way to do it. Another way to do it is to subtract these two angles out, so you get 160 degrees. And then you say, oh look, I have 160 degrees left to divide equally between these two angles, so I just divide 160 by 2 and I get 80. So either way that kind of like works in your brain better, either way is fine. Show your work if it's on a test. And there is one more example that we're going to do right now. This is a U-try. I am going to draw a kite, starting with the diagonals this time. We get diagonals on this one. Kite. I don't know why I have a hard time with kites, but there it is. This is kite X, Y, Z, W. And I am going to, let's see, okay. Oh, I have a point here, P. WP is 6. XP is 8. PY is 24. And PZ is 8. And I want to know what is ZY. Oh, not ZY. What is the measure of ZY? All right, so that's this one right here. I want ZY. Now remember, these are perpendicular to one another. The diagonals are perpendicular. So I'm going to just kind of cut out this triangle here. I have a triangle, 24 and 8. And I need to know what is that length there. And so I'm going to use, just like I did a couple lessons ago, I need to use the Pythagorean theorem. This is the hypotenuse, this is the longest side, so that's c squared, that's the one I'm looking for, equals 24 squared plus 8 squared. Okay, 24 squared is, oh, I don't know, what is 24 squared? 24 squared is 576 plus 64. 8 squared is 64. So I add those together and I get 640. C squared equals 640. Now I need to take the square root of each side in order to get what C equals. So the square root of 640 is approximately 25.3. So ZY is approximately 25.3. And that is your answer. And that is the end of chapter 6.